Hello and welcome back to the Coking.com channel. I'm Evan Hyde, your host, and I'm here on the shop floor at United Valve in Houston with Donald Polashik. He's a longtime plug valve expert here at United Valve. Could you introduce yourself just quickly to our audience?
Yeah, Donald Polashik, here with United. Been around the valve repair industry for a little over 40 years. Seen a thing
or two? Well, we appreciate your insight. What we have behind us is the two machines that they use to manually create the plug valves that we know and love in the delayed coking industry. So, Donald, could you kind of give us a rundown about what this machine is and how it works?
So, on a lift and turn plug valve, a big part of doing the repair is getting the proper fit on the seats. Not only taper, also finish.
Okay.
It's something that you really can't do with the conventional VTL.
Okay.
It requires grinding equipment because of the interrupted cut. So, in order to resurface the seat, the valve body would be put on this machine.
Okay.
And then the seat would be lined up as close as it could be based on what's there already and some other factors.
Mm-hmm.
And then the operators will go in with this grinding wheel and start to resurface that finish.
So you said you called it an interrupted cut. When you say interrupted cut, what do you mean when you say?
So
saying not a machinist guy.
If you're turning a shaft, for example, you've got a continuous piece of metal that the tool or grinding wheel is in contact with.
Mm-hmm.
When I say interrupted cut, you have to imagine the port going around. So whenever that port comes to the surface,
I see.
Causes a conventional tool to jump, but a grinding wheel will
okay.
come there.
So it's the interruption is the opening in the valve body itself.
Right.
Okay, got it. Okay, so this machine, it has the grinding head, that blue thing up there, and so the operator, as you described it to me, there's a bit of an art and a science to this.
Right.
So how would they actually get this very large and awkwardly shaped thing into this very precise position?
So it starts with using a dial indicator to line it up in terms of run out, and then matching the taper.
Okay.
Which the taper will have to be adjusted. You can see that head's on an angle.
Yep.
To match what's in the valve body. Could be off a half degree or something that needs adjusted.
So all of these like little.
So a dial indicator would be what they use to run around the circle and make sure they get that thing set on zero.
Just right.
Also run up the taper.
Okay.
To match the taper inside the valve body.
So it takes a lot of skill of the operator of this machine. It's not like a CNC machine where you just punch in the coordinates and it does its magic. There's a little finesse to this.
Yeah, so that's the first part of it, and that's very common with whatever you do on any type of manual machine.
Yep.
Right. The second part of it with this machine is once the operator starts grinding, he's got to adjust his table speed and its wheel speed to match the size of the body.
Okay.
And the materials on the seat. Harder materials, the far different feeds and speeds than softer materials.
Interesting. So it's a multi-dimensional problem.
Yes.
Well, so this is the machine that does the body. Let's pop over next door to the machine that does the plug itself.
Okay.
All right, and through the magic of editing, we've moved over here, and we are now next to the machine that does the plug. So Donald, kind of give us the same deal. What's the rundown about this machine? How does it work?
So the plug's a little bit different. It actually runs between the center in the chuck side and the inside.
So it gets trapped right there, huh?
So in terms of run out going in a round direction, not too big a deal as long as the centers are good.
Okay.
Sometimes we do run into a case where we got to send it back up front to have the centers reestablished. The real critical part of this machine in terms of fitting the plug is you already know what you have on the body.
Mm-hmm.
We've got to adjust this taper to get that matching taper with the body.
Okay.
We're looking for about a 1,000 clearance per side, maybe 1.5. So it takes some doing to get that taper to match.
Interesting.
And then once all that's done, still have to deal with finishes.
Yep.
They may have to adjust feeds and speeds. Grinding wheel is constant on this one, but we have rotating speeds that come into play.
So as this plug is being worked, it's spinning around this way, and it's also kind of being moved back and forth.
Correct.
As the grinder is going.
Correct.
Interesting. And
be like if you think about machining a traffic cone.
Okay. Not an easy task. So, how long would it take? You know, if we start with a plug that's sort of like rough cut to the shape you need, how long would it take to kind of taper it down to the precise dimension and finish that you ultimately need?
So once the body's done and we're working with just a plug, general rule is about a shift.
Okay.
About a shift to a shift and a half.
Interesting. And you mentioned finishes. I don't think we've talked about that yet. What surface finish are you going for?
We're looking for better than a 32 RMS.
Okay.
The better we can get, it's beneficial.
And when you say 32 RMS, just for the benefit of me and the non-machinists out there, what does that mean? Is that like mirror finish?
It's a roughness level. We'll look at some parts here in just a minute.
Okay.
That will give
you an example of what that RMS is. Okay, so perfect. Well, check back to our later videos. You'll be able to learn a little bit more about how the actual valves themselves look. But we thought this was an excellent opportunity to give you guys a behind-the-scenes explanation of how these valves are manufactured and repaired. So I want to say thank you to United Valve and Donald for sharing his expertise with our audience. So you're much obliged, sir. Thank you very much. And come back to the Coking.com channel soon for all things delayed coking. Thanks.